Hello, let's do Starstruck for Sunday, February 1st. We'll start with the easy, then do the hard, and I'll explain how this game works. This is called Giant 2. So, the rules of this game. Every single row must have exactly one star, every column has exactly one star, and every colored region has exactly one star, and the stars may not touch each other. So I can't put a star here and here. That would be disallowed because they touch diagonally. All right. So because every region needs to have one star, this region is only one cell big. So the star has to go there. And you'll notice that the automatic Xing X's out the rest of the row, X's out the rest of the column, and this cell, because none of these can be a star if this one is a star. Now that leads us immediately into brown here, where brown is down to, this is a formation that's extremely helpful and common, which is there's just two places left for a star that are next to each other. And so in this case, it's in the same row. So the rest of the row can't be a star, because no matter where we put that star, you'll imagine that these also will get eliminated no matter what. Can't have more than one in the row. But also these two, and the two above it, which are already X'd, touch both brown cells. So because they touch both brown cells, they're never going to be in either. All right. So what's next? Does that lead us into something with red or... Oh, we have the same formation in yellow here, and so that's extremely helpful. It gets rid of all those. Now there's only one place in light blue. Now only one place in brown, one place in this red. There are two places in green, but it does... Oh no, there's also these two places in green. Never mind on that. Two in yellow. Oh, but one... Oh no, sorry, green has four places. I keep thinking it's these two or these two, but no. Green is all one big S. Backwards S, 2. I suppose it's the 2. That's why it's called Giant 2. I get it now. All right, what are we doing here? I'm clearly just not scanning something. Oh, it's this orange. Sorry. Just sometimes I just not scanning the right thing. So we got this orange, and now it's in one of these two. So the rest of the row is out. That gives us the yellow. One of these two means that's out. So that gets us the gray. Now we get the orange. Ooh, uh-oh. No, I made some kind of mistake here because I can't place one in green. Which row is missing one? The bottom row is missing one. So did I... I'm just gonna restart, and I'm just gonna plonk it because I feel like maybe my explanations I got a little bit convoluted. So I'm just gonna do some simple plonking here and make sure I don't make a mistake. That's out because it touches these two. These are out because they're same row as green, so that's out. Okay. I probably made a mistake somewhere around here. So let's not make that same mistake. This column, this needs to be gray. Okay, yeah. So I must have X'd something I shouldn't have, or misclicked, or I don't know what. Anyway, let's move on to the hard. That one wasn't actually all that hard. I don't know why I messed it up so badly. Let's do the hard. It's called fenced area. All right, so you'll see this sometimes where an entire row and entire column are all one color. You have to do where they intersect, in this case, in this corner. Otherwise, that one of the rows or columns won't get a star, and you've already broken it. So we immediately get that corner. This touches all of gray. What else can I do here? Blue is close to needing the corner, but it doesn't actually need the corner. Oh, but the top row has to give its star. So this row must give its star to this dark blue because it can't give it to any other region, meaning that dark blue is X'd everywhere else. I'm trying to scan this. So we have 2 left in this column. And whenever you have 2 left in like a row, column, or region, what you want to think about is there a consequence that, oh, you know what we have? We have our typical, what they call an X-Wing. If you were to take a hint, it would probably call it an X-Wing. I wouldn't, but it's still a neat idea. So I'm gonna explain this carefully here. because it is both fun and important to understand this conceptually, because that will unlock all sorts of potential in your solves. All right, because it's a cool way of thinking about stuff. So, oh, I missed a row. Sorry. All right, I'm taking the time to do this properly. So, I've highlighted two columns here in between in between these and these. And so in two columns, we're going to have two stars, right? One per column. And I've also highlighted two rows. And in two rows, we're going to have two stars. Now, that doesn't mean we have four stars in total, right? Because I could do it at the intersections. If I do it at the intersection, then that's a star for both this column and this row. So I have 2, 3, or 4 stars within my shaded area where I've shaded two columns and two rows. But you may notice that in the cells I've highlighted, notice that like all of this column's been highlighted, this column's been highlighted, this row and this row. I have completely highlighted all of green, all of orange, all of red, and all of light blue. And we know that there's exactly one star in each region, and the regions don't overlap. So there is no overlap spot that I could put a star in the regions. So the result of this is that I must have a star in each of these regions, and that's going to end up being the star for each column and each row that I've highlighted. So it maxes out the stars. And so because the stars have been maxed out, first of all, I cannot put a star at their intersections because I need to be able to put 4 stars in the highlighted area. And at the intersection, that uses up an extra star because it's the star for both the row and column. But also it means that green, orange, red, and blue are going to use up the stars for these rows and columns. Meaning if you're not those regions, the rest of those rows and columns can get X'd out. And that is our result. That's what we get out of that. We get those eliminations. And that does leave it to these two. So those are eliminated. Now we have only 2 left in red. That touches this one. And this one. Because this touches this red in the same column as this one. Leaving 2 left here. So that takes out of all these. Okay. I thought I saw something, but I didn't. So I got to scan carefully here. What else can we do? Still one of these two. Oh, okay. So you'll notice that red and blue are now limited to these 2 rows here. So 2 stars in 2 rows. This is kind of a simpler version of what we just did. We're going to have exactly 2 stars because of the 2 rows. And then red and blue are going to use up red uses up one of the stars, blue uses up the other one because it's completely highlighted. And so as a result, this cannot be a star because it's in the same 2 rows. And that does let us place the yellow. Now we place the blue and the orange and the green and the red and this gray and that dark blue, and we're done. All right, that's a fun technique. You can imagine you could do like hybrids of that. You can combine rows and columns. You can even add regions into the mix and just like highlight a specific subset of cells where you know that there's a range or exact count of stars that must appear in them, and then compare that to another way of highlighting those cells or a subset of those cells. Anyway, in Sudoku, we would call that set theory, but I don't know if we would call that the same in this game. Anyway, that was fun. How'd you do?